Hello, and welcome to another SQL snack by the SQL Pro. In today's episode, we're going to discuss files, file groups, and TempDB. This is part of my series on performance tuning, so let's dig right into it. First, we're going to go through some theory before we get to our demos. So, first thing we need to understand is that modern database management systems have multi-threading capabilities. That means that the database engine can take advantage of this, and it can allow multiple processes to use one or more threads to complete work. And this relies on multi-core processors, as well as what Intel has produced, which is called hyper-threading. So that allows for multiple threads of work to go on at the same time. File placement, the size of the files, and the numbers of the files can actually improve performance or make it worse, depending on how you set these up. Data and indexes can be distributed across different file groups as well, which could help improve performance. So let's talk about data files first. Data files use something called a round-robin proportional fill algorithm, and I will give a little bit more details on the coming slides. So we need to make sure, first of all, that our data files are equally sized. We also need to make sure that we pre-size our data files in advance. Now, we make our data files equally sized so that the round-robin proportional fill algorithm works in a balanced fashion. And we pre-size our data files so that they're not growing while we're actually having transactions going on, because data file growth will use resources in your system. So you don't want it to consistently grow while you're having transactions come in, because it's going to use more resources. So when you pre-size, you're going to eliminate that performance hamper of file growth during your high or highly transactional or busy periods. Also, using separate physical disks when appropriate or available can help improve performance with data files. You want to make sure that you separate your log and your TempDB files. I would consider this to be a requirement. So you want to make sure that your data files for your user databases are on one physical drive, or separate on a SAN, physically separate from your log and from your TempDB files. So let's talk about the round-robin proportional fill algorithm. So let's take an example here. Let's say that you have two data files in your database. Here's data file number 1, and here's data file number 2. Now, as you insert records, what's going to happen is SQL Server is going to use proportional filling to start filling your data files. So your first record is going to go to this data file. And then your second record is going to go to this data file. And then your third record will go to this data file. And then your fourth record will go to this data file, which I would consider not a best practice. And it happens like this because the files are not equally sized. So because they're not equally sized, what SQL Server does is it says, okay, this is 1 gig file and it's 100% free, and this is a 500 meg file and it's 100% free. So for every 2 records that I insert here, I'm going to be filling the same proportion when I insert 1 record here. Now when we have the sizes spec'd out equally, what happens is when you start inserting records, they're going to be divided by the different files. So record 1 is going to go into here, and this has 500 megs free, 100% free of 500 megs, which makes it 500 megs free, and the other file is the same, right? They're equally sized. So the next record will go here, and then the fourth record will go here, and this will start to keep going on until the files fill up and then they grow. So the advantage of this is that for every record you put in file 1, in this scenario, the second record will go into file 2. So it'll be balanced and equally distributed, unlike the first example where you're having 2 records inserted for every 1 here because they're not equally sized. So this is a better scenario to have. Now, before we get to our demo, I want to talk about TempDB really quickly. TempDB is our server's community pool. Remember when you were a kid and you used to go to that one swimming pool that everyone used to go to? And remember what the little kids used to do, right? You know, they're in water and they can't hold themselves and the bathroom's too far away, right? So now that you got that picture in your mind, you're ready to learn about TempDB. So multiple files allows for multiple threads to use TempDB, similar to the proportional fill algorithms used for TempDB as well, just as it is for regular data files. So when you have multiple TempDB files, even if they're on the same physical disk, it will allow for SQL Server to perform better. And that's because there are these internal system pages. They're called GAM, SGAM, and PFS. And these internal pages help SQL Server allocate and track spaces for objects, like tables, for example. Therefore, when the contention is reduced, performance is increased. And this is kind of what it looks like. Let me put a drawing out here. So what happens is you have this TempDB file, right? And let's say that you have a second TempDB file. And TempDB is used by every process, right? Or every user. So what happens is there are these internal files here. They're system files. They exist in every data file, even your regular database files, your user database, excuse me. And what happens is, as somebody inserts data into a temporary object, SQL Server takes a lock on this page here. Let's say that this is the GAM page, Global Allocation Map page, and it wants to allocate a new page for your temporary object. So it takes a lock on this page, and then it finds the page that it can allocate free space to, and then it removes that lock. So let's say that you have multiple threads coming in. So those multiple threads, you know, each one is a different user. Let's say this is user 1, and this is user 2 and user 3. So they're going to have to start waiting for that lock to be released before they can get a lock on that system page, that internal page on your TempDB. And once that lock is removed, then they can start getting space allocated. So when you have a second file, what happens is other connections can start to use this other file. So let's say user 1 goes over here, right, and they're trying to get a temporary object, so they take a lock on this GAM page, and then user 2 will try to get a temporary lock on this GAM page so that they can get some data files, or pages rather, data pages allocated for their temporary object. So now you've reduced the contention. So user number 3 is going to wait for number 1, and then user number 4 is going to wait for number 2, for example. So you're going to have twice the number of files to allocate space in. So from a logical perspective, this is going to decrease contention, even if the files exist on the same physical drive. Which is why it's important to have more than one TempDB data file. So you should start with between 4 and 8, not exceeding 8 unless it's needed. There are studies that have been done that once you exceed 24 files, you get diminishing returns on any performance gains you would. And also, you need to pre-size them equally according to your workload, just like data files. So let's say that you restart your server once a month for patching. So before that patch cycle, just look at how large TempDB has gotten over that month. Let's say that it's about 50 gigs. So maybe you pre-size them to 60 gigs. And if you have 8 files, then you're going to pre-size each one equal size as well. And finally, you want to make sure that you test all of this before you push any of these changes to production. Alright, now it's time to get to our demo. So first thing I want to show is how to modify the TempDB file. So you want to do this during a maintenance window, of course. So this first statement here allows you to modify the TempDB file to change size and file growth, and the rest of these altered database statements are going to add additional files, data files, to TempDB. So I'm not going to run this, I've already done it in our system. here, and it's actually code that's widely available on the internet. Just use your favorite search engine. Now for the second demo, I'm going to create a database right here. Let me just make sure I don't have it. Okay, I'm going to create a database that has multiple data files. So I have a data file under this directory, and just for argument's sake, sorry, this is my second data file here. Let's say that this data file is on a second disk that's physically separate. I don't have that set up on this system here, but let's just pretend that file number 2 here is on a separate physical disk. I've created both at an initial size of 3 megs with file growth of 128K. I'm going to set it to simple recovery for this demo specifically. And I'm going to create a table with 3 columns. 2 of them are very large. And I'm going to show you what that looks like in terms of size. So row number 1 here is file number 1, and there's 104 free pages, data pages. This is the free space in kilobytes, and there's the free space in megs, and this is the current size. And then row number 3 here, this row has the information for data file number 2, and you'll see it has the same current size. It also has the same number of actually doesn't have the same number of free space or free pages, because usually the primary data file has some internal objects that are stored in there, so it has a little bit less free space upon creation. So I've done an initial insert of 1,000 rows, and now I'm going to show you what my data files look like. Both of them have 0 free pages, and both of them are the same size right now. So I'm going to execute this statement again, and I'm going to insert 8 rows every time I do that. So as you can see, the current size has increased to 5.25, number of free pages is 8. When I do another insert, number of free pages is 0. So what's going to happen is data file number 2 is going to increase in size the next time I do an insert. And as you can see, it's increased in size, and it has, during that increase, has freed up more pages. So every insert that I do takes approximately 8 pages of data. Every insert is an extent, essentially. And what happened is I grow it out to 128K in size, which is 2 extents. So every single time that I run this, I'm going to insert an extent, and after 2 inserts, my data file is going to grow. So now both data files are equal in size, so I'm going to turn this trace flag on, and what's going to happen is every time I insert, both of my files within the same file group are going to grow at the same time. So as you can see, both files have grown at the same time, and when I run it, my insert went to file number 2, and my next insert went back to file number 2. The following one will go to file number 1, and then when I run another insert, what's going to happen is both files will grow at the same time. And as you see here, they're both growing to 5.625 megs. And as I continue to insert, the round robin algorithm will proportionally fill both files until they are full, and then it will grow both of them together. So imagine if you have these 2 files on separate physical disks, what you're going to have is you're going to have, I wouldn't say necessarily double the I/O, but you're going to be dividing your I/O across 2 physical disks. Now I'm going to add a secondary file group, and in that secondary file group I'm going to add 2 data files, data file number 3 and data file number 4. And again, let's pretend that data file number 4 is on a separate physical disk. I'm going to create a new table on that file group. Now remember, a file group is a logical container for data files on your database. Now let's take a look at what's in that file. As you can see, we have 2 new files, and they both have 376 free pages. I'm going to do an initial insert here of 1,000 records. Alright, so let's see what it looks like now. You can see that both my files have grown, and both of them have free pages. And when I did the insert, file number 4 got more pages inserted into it. And as I continue to insert, my data files get full, and then they grow together as they have in the demo I just did a couple seconds ago. But as you can see, the other two data files are unaffected because the table I created was created on a new file group, and these two files are on that file group. So now I'm going to create a third file group, and I'm going to create a file, another data file in that file group, and then I'm going to create two non-clustered indexes on the table that I created in the primary file group. And this is really bad index design, but I'm using it for the purpose of this demo. So what I've done here, let me go up and start doing some inserts. What I've done here essentially is my data for the first table I created is in these two files here, and my indexes that I created are in this file here. So now I've separated my load between my data files and my actual data and the indexes that are built on that data. And that actually works for non-clustered indexes. If you create a clustered index on another file group, what it's going to do is it's going to move the actual data table to that other file group, because a clustered index is the actual table. So just keep that in mind. If you want to move a table between different files, an easy way to do that is to create or recreate the clustered index on a different file group. Now, as you can see when I'm inserting here, these two files are getting filled with data, and then this one is getting filled as well with index pages, because index pages also stored a little bit of data, particularly pertaining to the index itself. So I'm going to do a couple more inserts, and as you can see, my free pages now have gone down to 0, and finally my file has grown. Now, there are some schools of thought that would say you should not separate your indexes from your data because it makes recovery more challenging. So I'm not going to give my opinion either way, but it's just something to keep in mind if you're going to build your non-clustered indexes on separate file groups. Thank you, and I hope this has been beneficial for you.